Okay, everybody. Okay, first of all, let's recap some of the techniques that you have probably went through in your year one. Okay, these few standard techniques, you must be aware of it, right? Okay, to make sure you know them well. Okay, I just want to point out about this particular technique over here. The one concerning integration f prime fx power n, right? A lot of you know how to use this, but sometimes you find that if you have an expression presented in a different way, then you find that you are not able to handle it, right? Okay, let me give you an example here. Okay, supposedly you are told of this integration, right? Do you think you know how to apply the techniques and get it done? Right. Quite often you find that a lot of students do not know how to handle this. Alright, so I hope that just want to highlight that if you ever see this sort of expression, at least you must be able to recognize that you should try to rearrange it, right? Okay, rearrange it and see whether you can proceed to do anything using the techniques or not, right? Okay, so this is something that make sure you are aware of, right? How to do this type of integration, right? You know this, right? But when it's rewritten, right, in the form of a division, a lot of times students cannot recognize that form, right? So if you should try to check, right, whether are you having an integral of this type, right? If you have an integral of this type, make sure you just rearrange it in the product and then apply the same technique. Okay? So this is what you need to know, especially for this and this here, right? Then please recall that there are some standard trigo formulas that you need to be aware of, all right? Okay, make sure you know how to work out using the formulas for this sort of integral, all right? Especially take note that if you want to use the formula, you need to have a coefficient of 1 here in front of the x squared term, right? So make sure you get this form first before you apply your formula list. Another common type of integral that you encounter will be this type, whereby you have polynomial fractions, right? Numerator degree 1, denominator degree 2, right? So make sure you know how to split them accordingly, and then continue doing the integration. Right? So make sure you know that for this type here, and the other type whereby your denominator could be of higher power, right? Higher power. How do you handle this sort of question? Right? So later on, through the worksheet, we can cover some of these techniques. Okay, so I will not go through this further. Let's start with the worksheet. Okay, so you see that you have this with degree 3 over degree 3 now. So I hope you can recognize that the first step that you ought to do is simply to try out the long division. Right? Okay, so you always check the degree of the numerator and that of the denominator first, right? You need to proceed with long division and so on. Okay, so either you do the long division directly, or if not, you know what its form is, right? For example, in this case, you know that by division, you should get a constant, right, which is the quotient. So once you know that you get a quotient, which is a constant, then the rest, definitely you will continue with the use of partial fraction, right? So you can continue solving it this way, right? Alternatively, you just do your long division. After you do your long division, then you work out your partial fractions and continue evaluating. Okay, so I'm not going to show you the detail as to how you can find your unknowns and so on. Generally, what you should do is either you compare coefficients and so on, and that will allow you to find the unknown. Okay, so assuming we have found all the unknowns, and now we'll proceed with the integration. Okay, so you find that the first two terms quite easily done, right? Except the last term here. So maybe you want to give a thought and see how you can work out the integral for this third term. Any suggestions? Any suggestions? How about you? Any suggestions?
You multiply the top by 2, then you put a half.
Multiply the top by 2, okay?
Because you mentioned 3x, very good.
You get effect. Okay, all right, so we can try that. So in fact, if you try that, right, you notice that there is an extra constant term, right? Also, so what you always do is you check the numerator and denominator. The thing is always check the numerator and denominator first. Alright, then after you check that the numerator is of degree 1, denominator is of degree 2, you may likely want to explore checking the derivative of the denominator, right, which turns out to be 6x, right? So if you introduce 6x here, you need to take care of the extra constant term, right? So make sure you leave the constant term aside. Okay, let's see how we integrate the third integral here. How about the girl over here with the laptop? Any suggestion? What is the integral of this? Any idea? Or you look at the summary. Is there any techniques that we can apply? In the ln mod fx. Okay, alright. Okay, so for this third integral, you find that you can get the answer to be ln of modulus of 3x squared plus 1, right? So how about this one here? I hope for the fourth integral, you more or less know that you can look at your MF15 and then apply the formula, right? Okay, so that's how you solve this question. Right, so now what I suggest is that you take a look at your question 2, right? For question 2, and then revisit the formulas or the techniques and see how you can proceed, right? Okay, you may look at this, alright? Do you think this will help you to solve question 2? Or do you think the formulas in your MF15 are relevant? Any suggestion how to proceed using the technique shown here? How about you, yeah, fourth row? Seems you are quite prepared. Any suggestion how you would like to proceed? Split them. Means split the what? Split the x terms and the constant term. Split, okay, let's split them first. Alright, so sometimes you will find it's a bit complicated. You may like to consider splitting, right? So let's split them, alright. Okay, so now you look at this, right? Within the square root term, you have degree 2 polynomial. On top here is degree 1. Alright, so I hope you can realize that it is something which I mentioned just now, right now. Alright, one way is you try to check whether it is of this form, right? It is of this form here. So if it's of this form, then you can rewrite as a product again, and then apply the technique. Alright. Okay, so we rewrite it as a product, alright? And then you realize that if you differentiate 3 minus 4x squared, you differentiate 3 minus 4x squared, you get minus 8x, right? Yeah, minus 8x. So you just have to compensate with this constant here, so that ultimately you get your 2x here. Whereas for the second integral over here, I hope you are able to recognize that this can be done using your formula list. Right, so what you can do is you try to simplify first, right? Simplify first, so that hopefully, right, you get those integral of the form a squared minus x squared dx. Right, you can get this form, then you just apply your formula directly. Okay, so be careful after you factorize out your 4, make sure you take the square root of 4 and so on, right? Okay, so this part quite obvious. Okay, try to rearrange it in this form before you apply your formula list. Okay, whereas for this one, I hope you are able to apply the technique which I mentioned to you. It's of f prime times fx power n type, the one that you see over here. Right? So with this applied, then you get the answer. And then lastly, for this one, applying the formula. Okay, so just simplify after that. Okay, for question 3, right, you find that we have an integral involving a modulus function, right? So quite often you find that students are weak in dealing with this sort of question. So we have included this type of question in the remedial lecture. So I hope that you are able to learn how to work out this sort of question, right? All right, let's look at number 3 now. Right, so with a modulus there, you cannot possibly start the integration right now. So your aim is to get rid of the modulus. Now how then can we get rid of the modulus? So let's revise a bit of concepts involving modulus. Okay, remember your basics here. Modulus x is simply defined to be x or minus x. Right, if your x is at least 0, or if x is less than 0, right? Okay. Then you extend this further to that of fx. When you have modulus of this, then you simply get fx or minus fx. If right on, you have this. Alright. So with this understanding, actually very simple, right? What you should do is, based on the expression of your modulus fx, you should either try to rewrite as this or rewrite as this, depending on the range of x values whereby these are satisfied. Right? Okay, so we'll use this question to illustrate how you can get it done. Okay, for this quadratic function, right, you realize that it can be easily factorized, right? So x squared minus this plus this is simply this. Right, so you can recall what you learned in your secondary school, right? So with these factors known, you know that your graph looks a bit like that, with intercept at 1 and 3. All right, it should be symmetrical about 2. All right, this is your graph right now. Then if you can recall the graphing technique chapter, what is the modulus graph like? Right, the modulus graph will be like this. This part retains, this part also retains. The only part is this part here, whereby it's being reflected. Right? Okay. So you see that, right, for this modulus function here, this portion of the graph is exactly the same as this. Whereas for this interval here, your graph here is the negative of this. Can you see that? Alright, let's say this part here, this is actually negative of this. Negative of x squared minus 4x plus 3. Alright, it's the reflected part. Right? So whenever you do any integral with a modulus function inside, right, what you should do is always try to identify, right, maybe which part of the interval of x, right, your modulus function is exactly your fx, and which part your modulus function is negative of fx, right? So the very first step, one useful thing that you can do is try to just draw two graphs. Right, draw two graphs, one involving the modulus function graph, the other one without the modulus. Then you compare directly, right? As you compare already, then you notice that okay, from 0 to 1, this interval, the modulus function is exactly this, right? Then from 1 to 2, right, from 1 to 2, over this interval here, the modulus function graph here is just the negative of your quadratic function. So you split it this way, right? Okay, so I hope you got the technique right. So whenever you have integral modulus function, what you can do is get the two graphs drawn, right? One without the modulus, one with the modulus. Then compare them, right? Compare them, and then from there split your integral accordingly. Once you have split accordingly, then you just do as per normal. Okay, so sometimes you may have some problem, right? What happens if your integral function here has some unknown, right? Some unknown. Then you find that you cannot use your GC right now. So of course you can be more street smart now. Just replace the constant with some constant and then try exploring your GC to get the two graphs drawn, right? Then you from there you should be able to make some further inference how you can proceed further to split the integral of the modulus function. Okay, so the details here I think I'm going to explain. You can easily work out your integral on your own here. Okay, any questions so far? Okay, hopefully you know how to handle integral of modulus function after this explanation. Okay, another difficult topic is integration using substitution, right? In fact, if you have looked at the exercises that you've seen in your tutorial, the harder one are those involving trigo function, right? Trigo functions. Okay, so please learn how to do integration by substitution. Okay, let's look at this question here. Okay, maybe for this one I will elaborate more over here. Right? Okay, so you are given the substitution here, x equals to tangent t, right? Okay, of course, the first step is try to just differentiate it, right? Okay, so differentiate it. Okay, then you look at your integral. Okay, so your aim is to rewrite everything in terms of t, make sure you write everything in terms of t. So x is tangent t, so just replace accordingly. Alright. Square root, substitute in. Okay, then your dx has to be rewritten in the form of dt, right? So you rewrite accordingly. Okay, then after that you try to use your trigonometry concerning tangent square t plus 1 to simplify it. Okay, so 1 plus tangent square t is simply your secant square t. Okay, so you simplify with the cancellation of the second term. Okay, so after that you may want to explore further to see whether it can be further simplified, because you know that tangent t, tangent t is simply sine over cosine, whereas your secant is simply 1 over cosine and so on, right? Okay, so you just proceed to simplify further. Okay, so in the end you end up with this. Okay, so here maybe I pause a while, let you think how can we proceed to get this integration done, right? Any suggestions? How about the boy in yellow t-shirt? Any suggestion how to proceed? What technique do you think is applicable? Change to cotangent cosecant. Okay, so that's one method. After that, is there direct formula from there? Okay, so if you are good in memorizing all your formulas, you can do that, right? Alternatively, you can recognize that you have something of the form which you see over here in the summary, right? Something similar, you can see that. Okay, instead of looking at this side, right? Instead of looking at this form, you observe that it's something of f prime over fx power n now. F prime over fx power n. Alright? Okay, so you then straight away apply the technique there. Alright, so you can apply the technique, right? Because you realize that differentiating of sine will give you cosine. Okay, so you can apply the technique. Okay, but make sure you remind yourself, make sure you remind yourself that you cannot stop here, because you are given an integral that is respect to x, so ultimately you need to go and convert everything back to x term. Alright? So a lot of students are very weak in this sort of conversion. So I hope you can revise your lecture notes. There is an example that shows you how to deal with such conversion. You always try to use the right angle triangle to help you, right? Okay, so you look at your substitution that you were given. You are given x equals tangent t now. Okay, so therefore with this information, Okay, you have a triangle drawn here. Okay, let's say this triangle T here. So tangent T equal x round. So you may have x and then 1 here. Then this length will be known. Okay, so once you know the various length, and then you just look at the expression given here, sine t, right? So you want sine t. So what's sine t? Sine t will then just be x over this, and so on. No? So you just do the substitution, and so on. You should be able to get the answer, right? Okay, so I leave it to you to try to figure out how ultimately you can simplify to this. Okay, so you get your sine t in terms of x, then you take the reciprocal, and then you should get this expression. Okay, so just a quick summary. What are the techniques applied here? Alright, so first of all, you notice that you need to differentiate, right? You need to differentiate, rewrite your dx in terms of dt, and then replace all the x terms in terms of your t terms. Then of course, you should try to see how you can further simplify the expression that you have over here right now. If you see there is square root of something complicated, always try to see whether there is trigo identity to help you. Alright, after that, then you simplify further all the way, and then recap and see which technique can be applied, right? So finally, make sure you rewrite in terms of x again with the help of a right angle triangle if your substitution is the trigo term, right? Okay, let's look at number 5. Okay, for this derivative should not be that difficult. Any volunteers? Okay, how about the boy 5th row in yellow? What do you think differentiation of e power sine x over 2 should be? Half e what? Sine x over 2, yes, okay. Times cosine x over 2, correct. Okay, that's good, right? Okay, so make sure you recall the use of your chain rule, right? Okay, so you differentiate your exponential term, you still get exponential, but then make sure you differentiate your power. No? So when you differentiate your sine x over 2, then you get half cosine x over 2. Okay, so if you have tried sufficient questions here and there, you realize that whenever you see this sort of question of this format, right, you intuitively know that normally for this second part here, you should always try to tap on what you learn and obtain in part 1, right now. Okay? So you observe carefully and see is there any link right now. So you realize that over here you have cosine x over 2. But over here you have sine x only, sine x. Okay? So then you may want to recall what you learned about your double angle formula or your half angle formula. Okay, then you may want to consider splitting them first, right? Okay, so you apply your half angle formula, then you realize that through that you get this expression, which is what you have in your part 1. Okay, so after this, please learn to observe that when you have differentiation of this equal to this, you also realize that if you try integrating both sides, let's say for example here, you will have this result. Alright, so make sure you are able to interpret that. Differentiating this give you this means integrating this give you the e sine x over 2, right? Also keep this in mind, right? Because if you are able to observe this, then you see whether this can be deployed in the part 2 here. Alright? Okay? So I hope from this expression, you should now recognize that you should consider integration by parts, right? Okay, then ask yourself, what is the u and the v prime? What's the u and the v? Okay, so through this observation, you know integrating this into this, so you may want to consider defining your v prime to be this. Right? Then your u will be okay, if you want, you may include a 2. It's up to you whether you want to include 2 or if not, you can just factor out the 2. Factor out 2 and then just deal with the integral. Okay, so from here, then you get your v, which is this. So in your test and exam, do present your working like you can, right? What is your v prime, what is your u, and so on. And work out the v and the u prime. Then after that, do the integration by parts. Okay, so if you do the integration, I think you should know the formula. I hope you can recall the formula. Or you should get something like this, right? Okay, u and v minus this here. Right? Okay, so you want to try substituting all this inside here first and see whether you can do that. Okay, so you substitute everything that you have here inside here, and then you should ultimately obtain something like this. Okay, so I pause for a while. You take a look and see whether you are able to get what's shown here. Okay, sorry, yeah. So there should be a 2 here. Okay, because we have half integrating this equal this, right? So now with this, there should be a 2 here. Okay, so you work out your v times u minus integral of v times u prime. You should get this. Okay, once you get this, then you recognize that this is again what you have from part 1, right? So again, you deal with the integral of this using part 1. Okay, so I hope you can use this question as a reference, right? Whenever you see in exam paper, you see something of this format, part 1, part 2, one part asks you to differentiate, another part asks you to integrate, right? Try to see is there any link, right? And always learn to tell yourself to make inference that when you differentiate this and you got this, it will simply means that integrating your right hand side will give you your left hand side. No? Keep this in mind and see how it can be useful at times to deal with the next part. Okay, now we move on to question 6. Okay, so if you are familiar with your lecture notes, I hope you can recognize the sort of technique that will be deployed whenever you see a sine inverse term inside an integral. Normally, if you see inverse trigo function, it has to be done using integration by part. Okay? Alright, and I believe all of you know that you cannot integrate trigo inverse function directly, right? So therefore, the moment you recognize that you have an inverse trigo function here, this one can only be differentiated, cannot be integrated. Alright? So with the product here, you can then define your v prime and your u accordingly. Okay, so again, you work out using your integration by part formula. Okay, if you're not so sure how to differentiate sine inverse, refer to your formula list now. Please refer to the formula list. Okay, don't forget there's an x squared term here. So after you differentiated the sine inverse term, make sure you also differentiate your x squared. Okay, so this part obvious. Okay, simplifying this. Okay, you get this, right? Okay, so after going through so much about the techniques, maybe I hope that you can give it a thought and see whether you are able to do this or not. Give yourself a chance to evaluate your understanding. Do you think you can get this integral done? Okay, so if you find that you cannot get this integral done, that means you have not understood my lecture so far. Alright, so I hope all of you are able to get this done. What's the answer for this? Give it a thought first. Okay, if you need to, refer to the summary here. Okay, which technique is relevant? Is it obvious enough? Okay, so you look at this one here, f prime over fx. Definitely this out, right? Huh? Here you have fx here, or your integral have square root term, right? So you think of this. Alright. So if you can, try to rewrite in terms of a product, and then apply this technique to get it done. Okay, so all of you managed to get the technique applied. Okay, so you see whether you get this answer. So make a point to tell yourself, always try to recognize the type of technique. Okay, the rest is just simplification. Okay, for the second part, Ms. Ho will continue.
Okay, so first, if you look at question 7, okay, the first thing that I ask you to do is to find the coordinates of point A. Okay, and you know that if you want to find a coordinate of point A, be it whether, okay, the fastest way will be if you sketch the graph into your GC, then from there you get the coordinates. Okay, but before you do that, okay, there are a few things that you need to do first, because if you look at the equation given to you, it's not very nice for you to sub into key into your GC. Okay, so first, this I need to make y the subject scale of y squared. Okay, so if you look at this, okay, if once I take a square root, okay, please take note that once you take a square root, there must be plus minus. Okay, because I think some of you have the tendency to leave out the plus minus. Okay, so there must be a plus minus. Okay, so basically, which means that you will have two equations. Okay, one is this, okay, or this. Okay, and you have to recognize that these two equations actually correspond to two parts of your graph. Okay, so if you look at this, okay, oops, sorry. Okay, if you look at this graph, okay, your square root 4 minus x is always positive. Okay, so for this equation, okay, it actually corresponds to this part of the graph which is above your x-axis. Okay, because all the y values are positive. Okay, then for the negative one, y equals to negative 4 minus x, this will correspond to the one that is below your x-axis, because that's where all your y values are negative. Okay, so this is one thing that you need to recognize first. Okay, so this is your so that's why you have two equations. Okay, then if you look at the intersection, okay, your coordinate A is actually happening at the positive y values. Okay, so when you key into your GC, you can just key y equals to square root 4 minus x into it. Okay, then now, so I'll leave you to do that. Okay, the finding the coordinates. So I'll just tell you that the coordinates. Okay, so that's it. Okay, so now let's move on to the next part. Okay, so next part, they want us to find the area of the shaded region. Okay, so which on your copy is actually this part here. Okay, so I want to find the area of the shaded region. Okay, so when I find the area of this shaded region, okay, first thing first, okay, actually, there is no need for me to split it into different parts and look for the area separately. Meaning, there's no need for me to say that, oh, first I'm going to look for the area of this part, which I call A1. Then I look for the area of this part that I call A2, and I add them together. Okay, so there's no need for me to do that. Okay, I'm just going to find the area together. Okay, so first, okay, so first what I'm going to do is I'm going to integrate. So just now we know that this point here, the coordinate is actually negative 12. Okay, that's the x coordinate. Okay, so I'm going to integrate from negative to 12, this point, which is 4. Okay, I'm going to integrate here. Okay, and I'm going to integrate because if you look at the region, it's actually bounded by this curve here. Okay, which I know from the previous part, the equation is square root 4 minus x dx. Okay? And one thing that you need to take note of is whenever you are doing integration, whenever I integrate, for example, this, okay, when I do this integration, I'm actually looking at the area bounded by this curve and the x-axis. Okay, I'm looking at the area bounded by the curve of y squared 4 minus x and the x-axis. Okay, so that's what I'm looking at. Okay, so if I were to shape the region, okay, so if I were to shape the region, basically the one I'm looking at now is when I do the integral. It's this whole thing. Okay? But then you realize that it's not the one that I want, so I need to minus something that is redundant. Okay, which in this case I will minus away the area that is under the straight line. Okay, my straight line is given to you it's the same as this. Okay, so I'll just minus away this. Okay, and that's it. That's the area of the region. Okay, which I think most of you should have realized that actually I'm just using the graph on top minus away the graph below. Okay, so it's perfectly fine if you want to combine these two together. Then, before I evaluate, okay, you must always go back to the question and look at what they ask you for. Okay, I know they ask you for area, but are they asking for exact area or are they asking just for the area? Okay, it makes a difference. So if you look at this, sorry, is it exact area or area? Area. Okay, so if you look at this, they only ask you for the area. Okay, so there is no need for you to go and integrate it. You can just use your GC. Okay, because they never ask for exact. Okay, so basically you just use your GC and evaluate. So we just use your GC. You're okay with this? Okay, so now let's move on to question 8, okay, which is also on area. Okay, this one slightly different. So now you have a curve that is, you have an area, right, that is in your positive, sorry, that is above your x-axis and one that is below your x-axis. Okay, But then for this kind of question, okay, there is also no need for you to say that, oh, I'm going to look for this area, which is the one that is above my x-axis, then I look for the area under my x-axis, then I add them up. Okay, there's also no need for you to do that. Okay, similarly, you can also use the graph on top minus the graph below. Okay, so it's the same. Okay, there's no need for you to split into different parts. Okay, so for this question, okay, so if I look at it, right, so the intersection is from, the region is from 0 to 1, so I'm going to integrate from 0 to 1, okay, and the graph on top, okay, which is actually just, the graph on top is just, okay, so I'm just going to use this graph, okay, minus the graph below, which is my straight line. Okay. Which will just give you the area. Once again, if you look at the question, they did not ask for exact. Okay, so you can happily use your GC to evaluate it. How do you integrate it without using GC? Okay, so if you want to integrate this without using GC, okay, basically okay, if you want to know how to integrate without GC, so basically the one that is more difficult to integrate is actually this one, right? 0 to 1, negative 1 plus. Okay, so and we know that actually the troublesome term is actually this one. Okay, so I'm just going to focus on how to integrate this one. Okay, so first ask yourself, does this look like okay, first ask yourself, is it a proper or improper function? My numerator, the highest power is x, right? My denominator is x squared. Okay, so there's no need for me to do long division or anything. Okay, then the second question is, okay, so like what Mr. says just now, okay, there's a few forms that we can actually prove. Okay, so one of them is, does it actually look like this form? Does it look like this form? Kind of, right? Correct? Okay, because if you look, so if I take my fx, okay, to be equals to x squared plus 1, okay, then my f prime x will be equals to x in this case. Okay, so it somewhat looks like this form. Okay, but not really because there is a constant plus 1 here. Okay, so what I'm going to do next is I'm going to split this. Okay, so I'm going to split this. So it becomes x over x squared plus 1 plus 1 over x squared plus 1 dx. Okay, I'm going to split this. Okay, so once I split this, I realize that, okay, so this one is actually, I can rewrite it as which is now actually my f prime x over fx form, and I can integrate it. Okay? Then how about the other one, the one with the constant? Okay. Okay, let me write here. So this with the constant. Okay, unfortunately it's not in the form f prime x over fx. But then, in that case, what I'll do is I'll just go to my fx. Okay, and I realize that actually it's my tangent inverse. Okay, so that's how you integrate it if the question asks you for exact. Okay. For this question, okay, one thing for area, right? Okay, so for this question, I tell you that. Okay, for this question, I tell you that you can use the graph above minus the curve below. Okay, so in general, okay, it works. Okay, even if you have this kind of graph, okay, something that looks like this. Okay, then they ask you to find the area of this region. Okay, you can also use the graph above minus the graph below. Okay, no need to split into different parts. Okay, so it works in general. Okay, if you don't believe me, go back, look for your revision package or your tutorial, then you see whether got this kind of questions. Then you try to use the graph above minus the graph below. And splitting it into different parts, you will still get the same answer. The modulus. Okay. Okay, do you hear the question? The question is when do we need to put the modulus? Okay, so when do I need to put the modulus? Let's okay, instead of finding an example, let me bring it back to this. Okay, just now remember I said that some of you might try to find this area by using A1 plus A2, correct? Okay, so if I do that, okay, you realize that your A2, okay, this part, it actually falls under your x-axis. Okay, so when it falls under the x-axis, meaning that when you integrate your half x minus half, okay, this value is going to be negative. Okay, so this is going to be a negative value. Okay, but then you are trying to find your area. Your area is positive. So in order to make it positive, you just put a modulus, or you put a negative sign in front. Okay, so that's when. Okay, so this is a negative value, but if you want your A1, right, not A1, if you want your A2, okay, it will be either modulus of this, okay, or it's just the negative of. Okay, so if no question, let's go on to the next one. Question 9, parametric. Okay, for your parametric, one thing that you shouldn't be doing, or your last resort is, okay, basically you shouldn't be doing this. Please don't try to find the Cartesian form for your parametric equation and from there integrate and find the area. Okay, they give you parametric equation, you work with parametric equation. Okay, so that is the message. Okay, so basically when you see parametric equation, first thing, sketch. Okay, so basically they want you to sketch they want you to find the region. Okay, so I'll go change it to parametric first. Okay, then I key in this 2, which is okay. Then before I press graph, okay, always look at the parametric, the value of t. Okay, so if you look at this, your t runs from 0 to 1. Okay, so always go to your window setting and change it first. Okay, so I'll go to my window setting. So t minimum 0, t maximum 1. Okay, then I'm going to graph. Okay, you cannot see, right? Okay, not very clear. Okay, you have few options. You can do a zoom box or you can do a zoom feed. Okay. Okay, if you forget what those, please go back and revise on your graphing. Okay, so basically I'll do a zoom feed. Okay, so this is how my parametric graph actually looks like. Okay, then I'm going to transfer this. Yep. Okay, so this is how my parametric graph looks like. Okay, then it says that the area that is enclosed by the curve and the axis. Okay. Okay, and the line y equals to 1 minus power 4. Okay, so now what I want to do is I will try to locate where is my line y equals to 1 minus power 4. Okay, so by doing that, I will actually compare this and the equation of my y here. Okay, so I'll see, okay, what value of t do I substitute in, then it will give me y equals to 1 minus power 4. Okay, so one choice that you will make is t equals to 1, right? Okay, so I will okay, so when my t equals to 1, my y is equals to 1 minus power 4. Okay, then now you have another problem. What's t equals to 1 on the graph? Okay, so what you can do is always go back to your GC. Okay, so what I'll do is you can go to second calculate value. Okay, then it will prompt you for the t value. So my t equals to 1. Then it'll be like, did you see something blinking up there here? Do you see something blinking up here? Okay, so that's where your line y equals to 1 minus power 4 is roughly. Okay? So it's somewhere around here. Y equals to 1 minus power 4. Okay? So the region that I'm interested in will be this one. Okay, because it's bounded by the x-axis, the y-axis, and the line y equals to 1 minus power 4. Okay, so this is the region I'm interested in. So the next thing is I'm going to start integrating this. Okay, but to find the area, okay, one thing you should ask yourself, how is the curve, how is that region bounded? Okay, remember whenever you do integration, it's always the region bounded by the curve and your axis. Okay, so ask yourself, how is the region bounded? Okay, so in this case, do you agree with me if I say that this region R is actually bounded by the curve and my y-axis? You agree with me, right? Okay, so my region R, okay, maybe I'll just make a small note here, is bounded by curve and y. Okay, so what I'm going to do is I'm going to integrate with respect to my y-axis. Okay, so I'm going to integrate with respect to my y-axis. Okay, and where am I going to? So how is the whole region bounded? Is when my y is equal to 0 to 1 minus power 4. Correct? So that if I want to find the area, I'm going to integrate with respect to my y-axis, and this is the formula that I'm going to use. Okay. So now, but then you look at this, it's in x and y, but then you only have the parametric. So you go back and look at the question, then see how is your x and y related to the parametric. Okay, then you see that, oh, actually your x equals to t squared plus 1. Okay, so basically, it's something like a substitution. Okay, I'm going to sub my x to be t squared plus 1. Okay, then the next thing is, I'm done with my x. The next thing is, how about my dy? So I know that I can get dy if I differentiate my y equals to t minus tangent inverse t. Okay, so that's what I'm going to do. I suspect this is a touch screen. Okay, so I want to find my dy, so I will differentiate this. Oh. Okay, so that's how I have my dy. Okay, then the last thing that you must always remember to do is replace your limit. Okay, because your limits, right, your 0 and 1 minus power 4 is actually your y value. Okay, but now you're integrating with everything with respect to t, so always remember to change the limit. Okay, so we know that when my y equals to 1 minus power 4, my t equals to 1, so it's done. Okay, but now the question is, how about when my y is equals to 0? Okay, what is my t equals to? Okay, so basically just use this. Okay, so to find your t value, okay, you have two choices by observation. That's one. Okay, so if you observe, then you try to make a guess. Maybe t equals to 0, then you key into a calculator to double check that your answer is correct. Okay, another way is you want to solve for t. I'm going to use my GC again. Okay, so what I'm going to do is, okay, I'm going to exit the parametric mode. Okay, I'm going back to my Cartesian. So I'm going to key this in. X minus tangent inverse x. Okay, which you realize that actually is my y equation of y. Okay, so I'm going to key this into my GC. I'm going to graph this. Okay. I'm going back to Zoom standard. Okay, So then from here, I want this equation to be equal to 0. Okay, remember that's what I'm trying to solve for. I want to solve for this equation equals to 0. So I just, you know the story, yeah. Okay, so when y equals to 0, your s is equals to 0. Okay, there's some calculation, there's some algorithm error there. Okay, but it just means that your s equals to 0. Okay, so from here, I know that when my y equals to 0, my t is actually equals to 0. Okay, so with all this, I can now start doing my substitution, which is integrating my x, my dy, and the limits. And if I simplify the whole thing, it's very nice. Okay, unfortunately, the question asks for Sx, but fortunately, it's very easy to integrate. Okay, okay. Okay, so that's how you work with parametric. Okay, moving on. Okay, so I'm done with area. Okay, so that's all for your area. Okay. Okay, so then the next one, okay, we're going to go on to volume. Okay, for volume, before we solve the question, there is something that you need to understand about the formula. Okay, so for the volume, okay, you know that you have, if I am rotating it about your x-axis, okay, you have this pi y squared dx, correct? If you are rotating about your x-axis. Okay, so what does this, okay, and if you are rotating about your x-axis, okay, about your y-axis. Okay, so first thing that you must realize is, okay, depending on which axis you're rotating the whole region about, okay, you're going to use different formula. Okay, so that's the first thing that you should always look out for before you start solving the question. Okay, then the second thing is you need to understand what this formula gives you. Okay, so this formula actually gives you the volume of a complete solid form. Okay, so be it the one about S or the one, okay, this two gives you the volume of the complete solid form. Okay, so why? Because I think some of you are quite confused over why sometimes you rotate about 360 degrees, why sometimes you only rotate about 180 degrees. Okay, so actually I don't really care about that. The only thing that I'll ask myself is, after I rotate the region about 360 degrees, do I get a complete solid? If I get a complete solid, I'm going to use either one of this equation. Okay, then, or if the question says rotate about 180 degrees, after I do that, do I get a complete solid? If I still get a complete solid, I'm also going to use the equations here. Sorry, the formula here. Okay, so that is something that you need to know. Okay, what the formula is trying to tell you. Okay, so now with that, let's go back to this question. Okay, so for this volume question, before I start solving it, first I will always look about which axis. Okay, so because it is about my x-axis, so I know that I'm going to use the formula y squared dx. Okay, so first I identify which one I can use. Okay, then the next thing is I'm going to look at how many angle. Okay, so it's 2 pi radians. Okay, so if I look at this, my r, I rotate it by 2 pi radian, okay, which is 360 degrees, I'm going to get a complete solid. Okay, so it's fine. I'll just use my pi 1 square dx. Okay. So once I'm done that, so now I'm going to solve this. So my R, okay, is obviously involves two curves. One is y equals to x, and the other one is y equals to 2 over square root 3 plus x squared. Okay, so the first thing that I will normally do is I'll find the intersection between the two curves. Then because I'm rotating about x-axis, so I will draw one line down from the intersection to my x-axis. Okay, because why? Because most of the time it will very nicely split up the region for me. Okay, so I realized here that my R is now split up into R1 and R2. Okay, and I know that the volume of R is just equal to the volume of R1 plus the volume of R2. Okay, so that's what I'm going to find now. Volume of R1 and the volume of R2. Okay, so if I look at the volume of R1, okay, so same thing, like somewhat similar to your area is, my R1, when I do the integration, is always bounded by the curve, the region bounded by the curve and my x-axis. Okay, so if you look at your R1, it's solely bounded by the line y equals to x and your x-axis. Okay, so the volume generated is just from 0 to the intersection, okay, y squared, this. Then my volume of R2. Okay, yeah, and then we want to combine them together is also fine. Okay, so now my R2. Okay, so if I look at my R2, okay, it's actually bounded solely by this curve, 2 over square root 3 plus x squared. Okay, from 1, x equals to 1 to 3. Okay, so I'm going to okay, so basically the total volume, right? Okay, it's just then the same thing, I'm going to go look at the question. They only asked me to find the volume, so I'm not going to do integration. I'm just keying into my GC and ask my GC to give me the answer. Okay, question 10. Okay, so first part of question 10, they ask you to state the coordinates. Okay, so that's why you can use your GC. Okay, I'm just going to give you the coordinates. Okay, I know that the question only asks you for 3 dp, but can you give them more? Okay, because you need it for your next part. Okay, so at least give them to up to 5 dp. Okay, so basically, okay, for part 1, okay, how I will write down my answer will be okay, so basically you have 2, right? So one is 0.8. Okay, so this is, if you use your GC, these are the 2 sets that you will get. Okay, so these 2 sets, right, which is more accurate because there are more GPs, okay, you just leave it aside first, okay, because you need this later. Okay, so the answer will be the coordinate So although, basically the key thing is, although the question only asks for 3 dp, but you should take note of the one that has more dp because, okay, so now let's go on to find the volume. Okay, so basically this is your, oh, sorry, I forgot to mention one thing. Okay, if you look at the coordinates, right, is there something that you can infer from the coordinates? You look at the coordinates of points of intersection. Is there something that you can infer from it? Yeah, 0.34001281, negative 0.34001281. And you realize that the y coordinate is the same. Okay, and the x coordinate is just a negative of each other. Okay, so one thing that you can actually infer from here is it's symmetrical. The curve is symmetrical about your y-axis. Okay, so that's one thing that. Okay, symmetrical about your y-axis. Okay, it's going to come in useful. Okay, when we solve for the volume. Okay, so here. Okay, so now they want me to find the volume when it's rotated 4 right angles about the x-axis. So the first, similarly, okay, I'm going to ask myself, after rotating 4 right angles, okay, my region R, do I actually get a complete solid? I do get, right? Okay, so the one that I'm going to use is the formula that I'm going to use for this part of the question will be pi, because I'm going to get a complete solid. Okay, so okay, now solving this, okay, my R, first thing first, okay, do you agree that this whole region R, right, is going to also split it into my R1 and R2, correct? Okay, I'm going to split this into R1 and R2. Then the second thing is, remember just now we said that this, when I look at this set of coordinates, I know that the region is actually symmetrical about my y-axis. Okay, so which means that, okay, what this means is the volume generated by R is actually equal to the volume generated by R1 plus the volume generated by R2. Okay, but because it's symmetrical, these two curves are actually symmetrical about my y-axis, so this can be equivalent to 2 times the volume of R2. Okay, which is also equal 2 times the volume of R1. Okay, because it's symmetrical. Okay? And this makes things a bit simpler. Okay, so basically what I want to do is, all I need to do is, I just need to find the volume of either R1 and R2, and I multiply it by 2, then I'll get the volume that the question. Okay, so what I'm going to do here is, I'm going to find the volume of R2, okay, because I like to work with positive x values. It's just a personal preference. Okay. Okay, so first, remember just now when I went through question 9, I said I want, okay, before I do anything, I'll always look at the intersection, then I'll draw a line down. Okay, so if I draw a line down, then I realize that my R2, again, it's being split into 2 parts. One that is bounded by the red color curve, and one that is bounded by the blue color curve. Okay, so the volume of my R2 will just be equals to, from 0 to this point of intersection, which is, so from 0 to, okay, note here that I use more dPs, okay, because it's an intermediate set. Okay, then it's rotating about the x-axis, so I will have, okay, that's the red color curve. Okay. Then now it's also bounded by the blue color curve. Okay, so then I'll get the volume of my R2. Okay. For this answer, I also give to more SF because this is also my intermediate step. Because remember what they want? They want the volume of R, which is actually equals to the volume of R1 plus the volume of R2. Okay, so I'm actually not done yet. Okay, so my volume of R, okay, I know that it's symmetrical, so I have 2 times the volume of R2 here, which is just 2 times. Okay, so that's it. That's the volume generated by the whole region. So now, Okay, we are done with the x-axis. Okay, now they want to rotate about the y-axis. Okay, so one thing that you should observe here is, okay, for my y-axis, they only rotated about 2 right angles. Okay, but why is it that they only rotate about 2 right angles? Because if you look at region R, right, okay, I have 2 patch. Okay, so if I want to form a complete solid, okay, with 2 patch, one on the positive x, one on the negative x, right, I just need to rotate it by 180 degrees and I can get a complete solid already. Okay, so that is the reason why, for this case, they only rotate by 2 right angles. Okay, but then they are still going to get a complete solid. Okay, so that's one thing that you need to take note of. And because I'm still going to get a complete solid, okay, so what I'm going to do is I can still use pi integrate the formula, but this time around, because I am integrating about my y-axis, so it should be this x squared dy. Okay, so I can still use this. Okay, let me write a note here. Okay, so therefore I'm going to use this. Okay, so that's the reason. Alright. Okay, then now, if I look at this, okay, do you agree with me, right, that when I rotate the region R 2 right angles, okay, I'm going to, okay, so I rotate my region R, this is my region R here, okay, I rotate this 2 right angles, the volume or the solid that I'm going to get is the same when I rotate this region 4 right angles. You do agree with me, right? Okay, so basically the same volume in when rotate R2. Okay, so if you agree with me, then I'll just work with this diagram here. Okay, it's easier because there's only one side. Because it's the same, so I can use like this. Okay, so now if I look at this, I'm going to use integrate x squared dy. Okay, in order for me to use this, but then if you look at what the question gives you, it's always y equals to something for both curves. Okay, so before I start doing any integration, I will try to make x squared my subject first. Okay, so first one, which is the gray color curve. Okay, so if I rearrange it, I will get okay, so this for the red color curve. Okay, then for the blue color curve, which is this. Okay, if I rearrange everything, I'll get this. Okay, so I get the two equations already. Okay, in terms of x squared. So that's the first thing. Okay, then the next thing that I'm going to do is, okay, I'm going to now look for the volume. Okay, so again, like how I look for the volume when I rotate it about my x-axis, I'm going to do the same thing, which is I will find the intersection, then I will draw a line, but this time round to my y-axis. So I will draw a line horizontally, okay, to my y-axis. Okay, so if, give me a minute, I think I'll draw a new one, it's easier, there's so many animations on the old one. So I'm going to draw this line here. Okay, then do you realize that actually this line, the one that I draw, it also tells me how to actually find my volume. Okay, because if you look at this green color line, right, so you can see that one part, okay, so this point is 1.16. Okay, so if I were to integrate, okay, from 0 to 1.162, okay, the blue color curve, which is this, okay, this is the region that I'm going to get. Okay, this is the region I'm going to get. Okay, because if you look at it, this is the region that is bounded by my blue color curve and the y-axis. Okay, so when I integrate from 0 to 1.162, okay, this is the region that I'm going to get. Okay, so but then you realize that actually I do have something that is redundant. Okay, because the one that I want, okay, is actually just this part. Okay, but I have something that is redundant. So if I look at the redundant part, it's actually bounded by the red color curve and the y-axis. Okay, so I need to subtract it. Okay, from it's bounded by the red color curve and the y-axis when it's from 1 to 1.162. So once I subtracted away the redundant part, then that is the yellow one, the yellow highlighted part is the one that is left. Okay, so using my GC again. Okay, the volume back. Yeah, that's all.